lecture, I know we've been saying it, is way harder than this, and it's harder for you guys and harder for all of us. I'll think that's it'll be harder for me. It's physio. So I'm not going to be able to, I know it connects like fairly well, I would say. A lot of the physio stuff, I'm going to do my best, but I'm just not going to know it that well. So, and I'm not going to do cumulative reviews ever for physio, because it would take, some of these lectures next semester are going to take me like 4 hours to go over, like full. That's what I'm saying. Record them if you guys want to. No one has to come, it's okay. But once again, I'm going to do it once, and then I can answer questions later on, but I'm not going to go back over everything. Won't be that bad in the beginning, but some of these things are going to be very, very complex. So it'll be harder for you guys, it'll be harder for us too, so keep that in mind. We're going to do our best, but definitely sort of, I know it's still, you guys have way long to think about it, but prepare for that now. Just be ready for that. Like I said, I'll be doing Fridays again. It'll always be Friday, unless something comes up with an interview or something. Anyways, so yeah, let's go back. So once again, this whole lecture is thinking back to whatever that slide is, where it's like the, it's like the steps that we do to identify the target gene, the disease. Same idea here. So we've done all this stuff before here. Now we're saying we've identified possible genes. Now I'm going to look at those genes and say, well, what do those genes do? What is their normal function of that protein? And then, if we can say, well, this one is important maybe for interleukin receptor, or not interleukin, for an insulin receptor, and we're talking about diabetes, well, that'd be a good target. We could say, well, there's a good chance maybe this is the gene that's screwed up. Since this gene is traveling always within the haplotype block, that unique allele, if that's the bad one, then therefore that fits coding for the interleukin, the insulin receptor, well, that's a good idea for us to say, well, this is probably the one that's screwed up, and this is the one that's going to be responsible, or partly responsible, for the disease state. That's all that the slide is right here. Once again, no type 1 versus type 2. Type 1 is an autoimmune disease. Type 1, your own immune system targets your insulin-creating cells. The cells in the islets of Langerhans, which ones are they for insulin? Beta, right? They target the beta. I think they target more than just the beta, but the beta ones get killed. They can't make insulin. So what's a good treatment for type 1? Insulin. Just give you insulin, yeah. Type 2, on the other hand, is insulin resistant. So often with bad diets, if you're constantly eating a high amount of sugar, you're constantly making insulin, over time, your receptors, they basically aren't as effective. They need a higher amount of it to actually be able to actually have an effect. And in that case, we do have insulin in the blood, but now it can't actually go and function properly. Or in the other case, may not be an environmental thing. It could be the fact that you had a mutation. If we had a mutation in the interleukin, in the insulin receptor, now the insulin can't bind to it. You in effect have the insulin resistance, and now you don't have any effect. When you have insulin, what happens with the cells? What's the process? Insulin binds to the receptor. What do the cells do then?
Uptake glucose.
They take up glucose. If they don't have that occurring, insulin if it's there, but the glucose stays in the blood. Those are those high blood glucose levels that we see that are